Welcome to the third video in this series, and this one goes along with number 3 on your review sheet, the success criteria review sheet. So number 3 says, know what an energy conversion diagram is. Be able to create an energy conversion diagram. Study the examples that you have seen in your book. And I think the big thing from the book is to make sure the ones in your book are correct. Because if you can use your book on the test, then making sure that they're all correct will really help you out, because then if you're a little iffy, you can always look back at your book as an example. So be able to match an energy conversion diagram to a diagram and be able to explain why it matches. So on the test, you're not going to know exactly what type of question I'm going to ask. So for example, I could just say at position number 1, this ball is falling and it bounces. What I'd like for you to do is draw me an energy conversion diagram of it. Be sure to include any GE, KE, EE, and TE that it might have. Or I might come over here and say, hey, take a look at this right here. So for number 1, what I would like you to do is I would like you to take this. Maybe I wouldn't give you this. Maybe I would just say, okay, take this one, and where does it match up? Now you know it's 1 because I just crossed it off. But could you take something like this and figure out where it is if I took all the numbers off, say, and you had to match them up? Would you be able to do that? And that would be huge for the test. So maybe I'll have you draw it, or maybe I'll have you match it up. So when you look at this, know that it has elevation, so it's got GE. Know that it's falling, so it's got KE. So I can even look at this and say, okay, the KE is increasing, GE is going down. So that would be another good way to tell me. Does it have some thermal energy? It does. It's got some thermal energy because it's going through the air. So there's going to be that friction between the ball and the air. So when it's touching the ground down here, so we lost all the GE. We do have some KE yet, because as it's hit, it still has to squish and get your EE. Now if it hasn't squished yet, you don't have any EE. But you're still going to have a little thermal energy. Now when it's at its maximum right there, it's got no KE anymore. It's still on the ground, so it's got no GE. But it's still going to have some more thermal energy, because now not only did it hit the ground, or was going through the air and hitting the air molecules, now it hit the ground, so it's got even more TE. And then you see it slowly, well, ideally this would be a little less and a little less, because you would see that it's slowly losing its thermal energy as it's going up. It'll be more like this at the top of the bounce. Maybe not quite as low, but you're going to see it lose a little bit. But notice, once it leaves the ground for 5, it leaves the ground, so now it has GE again, and that GE is actually increasing, and then the KE is decreasing as soon as it leaves the ground, which is kind of confusing because here it has no KE, so right here it's actually starting to pick up KE, but once it leaves the ground and you got GE, now the gravity's pulling it down, it's going to slowly start losing KE. So make sure you understand this, make sure you ask if you need more help, but be able to go either way, be able to draw an energy conversion diagram, or be able to match one up. Thank you. Make sure you ask questions if you have them.